Bismillah. Good morning, class. So at this point we're busy with graphs. Okay, you had some homework yesterday? No homework, no problem. You had to, Pythagoras. Okay. But you had no homework on the graph section. Okay. Right. I'm supposed to check your books now, no? Yes. I can check it every day. There's nothing wrong with it. I'm supposed to check for Pythagoras today. Monday. Alright. No problem. So don't forget you're writing a test on Monday again, okay? I think from now onwards we're going to start implementing that your class test is an account towards your term work. I think we should be doing that. Okay, so that it can be a continuous. Hello, come in. So it can be a continuous revision, and you guys can start taking it serious. So from next term onwards, so it's a fair warning now. From next term onwards, that class test should count something towards your term. Okay. Sorry? Yes. So by doing your homework every day and all of those things is studying or preparing you well for the exams. Okay. So yesterday the last note we made was the graph of y is equal to mx plus c using the intercept method. And we said the method is one, finding the x-intercept by letting y equal to 0, then finding the x-intercept, the y-intercept, let x equal to 0. And 3 is to plot 2 points, then draw the graph. Alright, but we haven't done any examples on that yet, not so. Let's look at the first example. And this is the example 1 on page 66. Is that correct? Example 1, page 66. Right, write that down. Example 1 on page 66. So, what's the first thing we need to do? What do you say? What's the first thing we need to do there? The first step was to work out our x-intercept. How do you calculate the x-intercept? We let y equal to 0. Not so? So if we look at this equation here, again, why are we letting y? Who can remember? We mentioned it yesterday. Why do you think we're letting y equal to 0 to calculate the x-intercept? I said it yesterday. No? Yes? Who can remember what did we say about the y-intercept, the x-intercept? Let's go back. We said that anywhere on your x-intercept, your y is going to be 0. You remember I said that yesterday? Anywhere on your x-intercept, y is equal to 0. And anywhere on your y-intercept, x is 0. Hence the reason why, when you work out x-intercept, we let y equal to 0. We work y-intercept, we let x equal to 0. And that's the reason why. You guys understand? So, with that information we go, okay, x-intercept, let y equal to 0. So here's a y here, not so. So 0 is equal to negative 2x plus 4. Negative 2x plus 4. So solve for x quickly. Solve for x. Then you do the same for y. So y is equal. So what do we get? Take it over the equal sign, so 2x is equal to 4. Divided by 2, so x equal to 2. Right, you all agree with that? So what's the next thing we need to do? Is our y-intercept. What do you do for y-intercept? Let x equal to 0. So do your thing there quickly. So y is equal to negative 2 times 0 plus 4. Anything times 0 is 0. So y is equal to 4. You all okay with that? What's the third thing we need to do? Sorry? We are told to plot the 2 points through the graph. So if you now go on the Cartesian plane. Remember, this is your x-axis or your x-intercept, and that's your y-axis, your y-intercept. Where the graph is going to cut, your x-axis is called your x-intercept, and the point where the graph cut your y-axis is called your y-intercept. Okay? So x is 2, so we mark 1, 2. More or less evenly spaced. Can you see that, people? I'm not going to draw the graph like this, like 1 here and 2 there. That's clearly not correct. Not so. We make it evenly spaced, more or less. And 4, remember this is the positive part of your y-axis, the negative part of your y-axis. Not so. So on the positive part, it's going to cut at 4. There's 1, 2, 3, 4. Those can be the lines on your page. Okay? Just make little strokes there. And with a ruler, why are we using a ruler? Because yesterday we saw that the linear graphs forms a straight line. Not so?
Yes, sir.
So with that said, we now take a ruler, as you see me using. I draw the line there, going through the 2 and the 4. It goes through that point on the graph. Can you see that, people?
Yes, sir.
There we go. You guys understand? Don't understand? Let's do another one. What's the gradient of this graph? What's your m value? Negative 2. What is your c value?
Plus 4.
Plus 4.
Yes, sir.
But you also said c is what? C is also your y-intercept. And what's your y-intercept here? 4. Can you see that, people?
Yes, sir.
The gradient is negative. So the graph is going down. What did you say down is? Decreasing. Can you see that, people?
Yes, sir.
Okay. Let's do another one. Yes? Still writing. Here's the next graph. I'm going to pause the video at this point, and then I'm going to come check your books now, okay? Alright, so now we're looking at example 2. So x-intercept, what do you do for x-intercept? We let y equals 0. So 0 is equal to half x minus 3. Make a habit of writing this x-intercept with y. So what we do, we solve for x. So you got over, you got negative half x equals negative 3. So what do I do now? Divide both sides by negative half. So that cancels. So x is equal to negative divided by negative is positive. And 3 divided by half. How many halves are there in 3? There's 6 halves in 3. There's 2 halves in 1. 4 halves in 2, 6 halves in 3. Okay. But okay, for those of you who didn't know that, we change this to multiplication. So it's 3 times 2 over 1, which is 2. So we'll give you 6. Secondly, y-intercept. What do you do for y-intercept? Let x equals 0. So y is equal to half times 0 minus 3. Negative 3. So again we draw on a different system of axes, not on the same one as the previous. Okay? X is 6. There's 1, 2, 3, 4, 5, 6. And y is negative 3. 1, 2, 3. Not so? There's your origin. So when we draw, graph is going through the 6 and the 3. So there's a graph. Make sure it's going through 3 that is marked on the x-axis, on the y-axis, negative 3, and 6 that is marked on the x-axis. Mustn't go through the number negative 3 and 6. It goes through the point on the x-axis at negative 3 and negative 6. Do you guys understand? Yes. Any confusion? Let's do another one. I'll pause the video again and then I'll come check again on you guys, okay? So now we're going to draw 2 lines. Sorry? The calculations will be done separately, but you'll draw it on the same graph. So example 3. Again, I'm going to pause the video at this point. Alright, so let's look at these 2 quickly. So I'm going to bring my axis in here. I see many of you are drawing your axis freehand. Or your points freehand. So what you should do is, you must take your ruler when you draw your x-axis and you're drawing your y-axis now. No? The first thing we put in is a 0.
Mr. Bodine?
Yes, miss?
Asima Khalid, can you send it to the office, please?
No problem, miss.
Thank you.
Okay. So, these lines here are the lines in your books, not so? So you go normally 4 or 5 down and up. Then you take a ruler and you measure on your ruler, as you see me doing here with this ruler. I put that on there and I measure 1 centimeter per unit. Okay? So most of you are doing it. But I see some of you are not using a ruler. Okay? So if we look at the example in question here, so make this graph a bit smaller, or the Cartesian plane a bit smaller. Okay. So we started off, we're going to do all the calculations of that graph in blue. So for y is equal to 4x plus 1. We worked out our x-intercept. What's our x-intercept? We let y equal to 0. So you say 0 is equal to 4x plus 1. Not so? We take that over the equal sign. So negative 4x is equal to 1. Divide by negative 4 both sides. So x is equal to negative a quarter. Number 2. Y-intercept. What do you do for y-intercept? We let x equal to 0. So y is equal to 4 times 0 plus 1. 4 times 0 is? 1. So 0 plus 1 is 1. So x is 1. So if that, sorry, y is 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Minus 1, minus 2, minus 3, minus 4, minus 5. 1, 2, 3, 4, 5. So before I plot the point on the axis, I must make provision for the axis already. I must have written my scale in already. Because what I'm seeing also, some of you is making, that's my quarter, negative a half, 1, and you can't just make it anything you want. Okay? So x is negative a quarter. If that is negative 1, then negative a half will be there, negative a quarter will be approximately there. Not so? You go negative a quarter. So we'll take that other stuff out. So that's going to be negative a quarter there. And 1, which is there. So negative quarter and 1. So I take my ruler and I draw the graph going through those 2 points. Okay. You all okay with that, people? So now let's do the other calculation. Let's do that in red. For the graph y equals 4x minus 2. Where do we start off? Y-intercept. What do you do for y-intercept? Let x equal to 0. If you go and calculate your y-intercept first, no problem. Calculate your x-intercept first, no problem. Okay? Y-intercept, let x equal to 0, so y is equal to 4 times 0 minus 2. 4 times 0 is 0 minus 2 is negative 2. Then we work out our x-intercept. What do you do for x-intercept? Let y equal to 0. So 0 is equal to 4x minus. So what do we do now? 4x over the equal sign. So it becomes negative 4x equal to negative 2. Now what? Divide by negative 4 both sides. So x equal to negative divided by negative is positive. So y is negative 2 on your y-axis. As you see me putting a dot there. And x is equal to a half, which is approximately there. Again, with the ruler, we draw this graph. Going through that point there, and that point. Not so. What do you notice about these two graphs? Remember, this one is the y equals 4x plus 1 graph, and this is y is equal to 4x minus 2. What do you notice? Both is increasing. What else do you notice? Straight lines. What else do you notice? They're parallel. Okay. My graph is not nicely drawn to scale, but if you look at this graph here, let me just pick this graph up here. Okay, if I draw this graph a bit more, you'll see the graph looking like it. And the lines are absolutely parallel. So, if you look at the two graphs, what is the same of these two graphs? The lines. Now I'm talking about the equations. Sorry. What do you notice about the equations?
They both have fractions.
Well, there's a fraction as your x-intercept, yes? I'm talking about the equation. The equation is y is equal to 4x plus 1 and y is equal to 4x minus 2. What is the same there?
4x.
The gradient is the same. Can you see both is what? You see here both gradients are the same. So we say since the gradients of the two graphs are the same, what can we say? Therefore, the lines are parallel. Or we can say the graphs are, it's rather say the straight lines are parallel. The lines are parallel. This is a very important concept to understand at this point. Yeah? But to draw this graph, 3 marks, 3 or 4 marks. If the gradients of the two graphs are the same, therefore the lines are parallel. Very important to note this one. If lines are parallel, gradients are the same. Gradients are equal. Lines are parallel, gradients are okay. Okay. And there's their note that they wrote. There girls, come in. Stop having your own conversations. We are told the lines are parallel because both is equal to 4. As mentioned before, m is the slope, inclination, or the gradient of the graph. Not so? And you can put this in a box. M the same will result in lines being parallel. Why do you think the arrow is going both ways?
Equal.
No, this is equal is going there with that. It implies that it can go both ways, either way. M is the same, then lines are parallel. Or, if lines are parallel, M is the same. Okay, that's basically what they're trying to denote at this point. Okay. Right, for homework, out of the exercise on page 71, for homework on exercise page 71, I want you guys to do the following. There's only one exercise in this, there's only one exercise on this, on this topic. So the exercise is comprehensive. So I'm going to break this up for you guys, okay? So you guys are going to answer. I'm going to highlight for you now. Just give me a chance. It's out of the Study and Master, my girl. Study and Master is. Exercise 1. This is the only exercise on page 71. Okay. So, the sums I want you guys to do for homework is as follows. Out of exercise, this is the only exercise in this chapter. I want you guys to try and see what you can answer out of number 1. Yeah, I don't want to give you just the answers. See who can actually come up with these answers, okay? We'll discuss that tomorrow in tomorrow's lesson. But this is more theory. Question 1 is more theory. Yeah? Number 2, theoretical. Number 2, it asks you to draw the graphs of each of the following. Now we haven't dealt with all the graphs yet, okay? So you're going to do all of number 1, number 2.1, 2.2, 2.3,
Miss Eli is
4,
selling burgos
5,
from the consumer studies room,
12,
and it's selling for 25 rand, as well as water and juice. Burgos coming for 25 rand at the consumer studies room. Debating will be in room 19.
then
And
1,
the
2,
topic
3,
will
4,
be
5, 6, 7, 8, 9.
Lobola is sexist. Debating will be in room 19, and the topic will be Lobola is sexist. I have a water bottle, 2 pair of spectacles, and a wallet in lost property.
Okay.
A water bottle, 2 pair of spectacles, and a wallet in lost property.
Okay. So this number 1, 2.1, 2.2, 2.3, 2.4, 5, and 6, 2.12, 2.14, 15, and 16. The other sums we weren't exposed to yet. I'm sure some of you can do it already, but don't do it yet. That's for homework. People, enjoy the rest of your day. Good morning, class. The bell ring already. There we go.